Hi, and welcome to this video on transformations, vertical and horizontal reflections. Okay, so we've been talking about transformations for a while now. We talked about translations. So those are our location changes, so our shifts for X and Y, horizontal and vertical. And then we talked about dilations, which change the size of our functions because it multiplies it or divides it by a certain factor, either in the horizontal or vertical direction. Okay, so you got some practice problems last night, and hopefully you did okay with those. Go ahead and check your solutions, and if you have any questions on any of those, then hopefully I can answer those for you next class. But the key is to do one transformation at a time. So in this case, we're going to look at the reflections. Okay, so reflections are pretty easy because there's only two things that can happen with a reflection. So our goal for this lesson is to answer the question, how do reflections that apply to f of x or y in a function change the direction of the graph? So we learned that translations change the location of a graph. It moves it, shifts it, or whatever. Dilations change the size of a graph, and it expands it or contracts it or shrinks it or it compresses it, right? Or shrinks or stretches, right? So what we will learn with reflections is that it changes the direction. So it flips our graph horizontally or vertically, okay? So let's look at the following equation. So the parent function y equals 2 to the x. So we're going to start with the exponential this time. We have two ways that we can write this. So y equals 2 to the power of x, to the power of negative x will change our function, and y equals negative 2 to the power of x will change our function. Okay, so let's see how those two are affected. Well, the first one, the negative is being applied to x, so it's going to reflect the x values horizontally over the y axis. Okay, so let's see how that happens. Remember we said start with a few key points that you know that you can easily find. So in this case, let's start out with the point 0, 1, and then for this point we have negative 1, 1/2, and for this point we have negative 2, 1/4. Okay, and then let's go to the other side where I have the point 1, 2, and then where I have the point 2, 4. Okay, and I can even go all the way up here to where I have the point 3, 8. Okay, so let's look at how applying a negative to x will affect our graph. Well, if you negate x, what's going to happen is you're just multiplying your x values by negative 1. So when you do that, if your x value is negative 3, 8, the new point, if your x value is positive 3, 8, the new point will now be negative 3, 8. So it's going to reflect to the other side. This one is 3 away. This one is now going to be negative 3 away. Okay. This one, 2, 4, will become negative 2, 4. 1, 2 will become negative 1, 2. And negative 1, 1/2 will actually become positive 1, 1/2. So your x values just switch places. Negative 2, 1/4 will become positive 2, 1/4. So what you get is a function that has mirrored itself across the y-axis, right? So remember that this is your x-axis and this is your y-axis here, okay? So basically the function just turns itself around horizontally. Your x values just mirror themselves on the other side of the axis. Okay, now let's look at what's going to happen vertically, okay? So when we have that negative 2 outside of 2 to the power of x, right? The negative is outside. It's like taking your y values and multiplying them by negative 1. So this will reflect y values vertically over the x-axis. Okay, so how will that look over the x-axis? So that one, if I have the point, going back to our key points, 3, 8, it's the y values that are being negated now. So 3 will stay the same, but now it will be 3, negative 8. Okay, same thing here. 2, 4 will become 2, negative 4. 1, 2 will become 1, negative 2. In this case, the y-intercept is affected because it's 0, 1. The y value actually has, the y intercept actually has a value for y, so that will become -1 because those are the ones that we're negating. And -1, 1, 2 will become -1, -1/2. Excuse me, did I say 1, 2? I really did. Okay, -1. So -1, 1/2 will become -1, -1/2. And -2, 1/4 will become -2, -1/4. So what you get is a mirror of your original. So this one has moved that way, has reflected or shifted, not shifted, excuse me, reflected down across the x-axis. So it flipped over the x-axis. So you could think of this one as kind of rotating down vertically, and you can think of this one as kind of rotating horizontally. Okay, so it flips around, so the points switch places. All right, let's look at the cubic one. Okay, so for this one, the same thing will happen for the x. For when x is inside the parentheses, that's being applied directly to x. So for the cubic function, a negative reflection on x will reflect x values horizontally over the y-axis. Okay, so let's look at what happens. So this is my point. It's x cubed, so this is the point 2, let's see. Yeah, so everything is cubed, so this is the point 2, 8, right? And then this is the point -2, -8. And this is the point 1, 1. And this is the point -1, -1. And then, of course, we have 0, 0. Okay, so how will this one be affected? Well, if I'm reflecting it, the x values across the y-axis, then these will go here, right? So that one will come there, and this one will become -1, 1. So 2, 8 will become -2, 8. 1, 1 will become -1, 1. In this case, -1, 1 will become +1, -1, and -2, 8 will become +2, -8. So what happens is I get a function that looks like this. It's just a reflection. Okay, so kind of like an hourglass type looking thing. Okay, so let's try with the negative outside. Okay, so in this case, the y values are going to be reflected. So we will reflect y values vertically over x axis. Okay, so for the y values, the point 2, 8 will become -2, 8. And the point 1, 1 will become, 2, 8 will become 2, -8. 2, -8, excuse me. And then the point 1, 1 will become 1, -1. And the point -1, -1 will become -1, 1, because it's the y values that are changing. And the point -2, -8 will become -2, +8. And so what you get is this one actually ends up being the same as the other one. So I'm going to kind of draw them side by side. They both look the same because whether you reflect it up or down, since the cubic has rotational symmetry, then its rotation or its reflections will actually look the same in both the horizontal and the vertical direction. All right, so let's try the last one. Y is equal to the absolute value of x. So we know what's going to happen. So x values will be reflected horizontally. So I'm going to draw an arrow